Okay, so now that we got all our terminology down, let's go ahead and look at some problems, on quizzes or homeworks or just in other classes that you might have to think about. All right, so we're basically going to use all that lingo. So in the first stanza, all right, I got a couple of problems, and in both of them, I want us to create just one polynomial that satisfies all the given characteristics. So here's three characteristics that one polynomial has to satisfy. So first of all, it's a binomial. So what does that tell us? It has two terms. All right, so there's two terms involved. So maybe there's just one addition. The next thing, it is a degree 2 polynomial. So whatever variable I have out front here, it has to be to the second power. All right, and then the lead coefficient is -3. Well, if my polynomial is degree 2, that means the highest degree power is 2, which means the leading coefficient is the number part of that. And so putting in this ascending order, right, perhaps I just use 5 as my second term. And so I've just created a binomial, right, two terms of a degree 2 polynomial with the leading coefficient of -3. There's actually an infinite number of examples. The one thing that's fixed is the first term. That's because we're degree 2 and leading coefficient is 3. But if I wanted to, I could have had something like 7x, right? That's another example of a degree 2 polynomial that's degree 2 with a leading coefficient of -3. I don't even need to use addition. I could have used a subtraction. So maybe we subtract something like 2y. All right, and so again, we have a binomial of degree 2, right, highest degree, leading coefficient of -3. So there's actually an infinite. You're probably sitting at home watching this. You can probably come up with more. There's an endless amount. Okay. The next one, we're talking about a trinomial. So that basically tells us we have three terms. It is a degree 4 polynomial. So no matter what I have, the highest degree term has to be of degree 4, right? And then the leading coefficient has to be 7. So that basically says that my first term needs to be 7x to the fourth. Since it's a trinomial, I can basically build any other two terms. So how about I just put plus x and plus 2. So here's a trinomial, three terms, of degree 4, right? Highest degree is 4, with the leading coefficient of 7. And so there's one answer. Of course, here's potentially another answer, right? That also satisfies the condition that we're a trinomial of degree 4 with leading coefficient of 7. So again, there's an infinite number of answers. So there's two that came off the top of my head. I'm pretty sure you can come up with others. All right, so that's, again, notice I'm using the lingo that we've learned, putting it together to create one polynomial that satisfies a bunch of given characteristics. Okay, another item that's commonly occurred in your homework is they'll ask you to do a lot of things. So I have 4 polynomials here, and for each one of these polynomials, they want us to determine the degree, I should probably say, of the polynomial, right? Determine the lead coefficient, and then determine the coefficient of the x squared term. All right, so we have a lot of things going on. So how about for each one, why don't we just talk about the degree of the polynomial first? So again, that's the highest power, all right, highest degree term that I have in each. So what's nice about the first one is it's already in descending order. So there's my highest power. So this is a degree 4 polynomial. All right. For number 2, right, when I look at this, it's not in descending order. So perhaps we change it, or if you can just kind of take a look, there's the term with the highest degree power. But how about we just go ahead and rearrange this so we got it. So we have 5x to the 7th. It looks like the next highest degree is the 5th, and then the next one is 11x squared, and then plus x squared. So the highest degree power, so the degree of the polynomial in this case would be 7. All right, and then number 3, again, we're not in descending order. As a matter of fact, we're in ascending order. So maybe we take the time to rewrite it, and it looks like the highest degree term is 3. Okay, and then number 4, it's got all kinds of issues, got fractions and whatnot, but I can see right now that the highest degree term right, is right there. And I'm going to put that in descending order a little later, but it looks like this is a degree 3 polynomial because the highest degree is 3, right? So we've just done the first one for all 4. We determine the degree of the polynomial. Next part is to determine the lead coefficient. Well, again, if you're in descending order, right, that lead coefficient is out in front with the highest degree power. So the lead coefficient for each one of these 4, right, is -5 for the first one, +5 for the next one, +2 for the next one. And even though I didn't put it in descending order, right, that is the highest degree term. So it's 4/3 for that guy. All right. So again, the leading coefficient is the highest degree. It's the number part of the highest degree term. So we've just handled that. And now what we want is the last one is what's the coefficient of x squared, right? The x squared term. So that means we're going to go look at the term that has x squared in it and look at its number part. So looking at this first one, right, here's the term with that's x squared, and the number part is actually -1. All right, because again, if you go back to subtraction, subtraction is the addition of an opposite. So this would be a -x squared term. So the coefficient of x squared is just -1. In the next one, as I'm writing this out, right, we have this x squared kind of sitting off by itself, but there is a 1 technically in front of it. So the coefficient for x squared there is 1. All right, and then number 3, when we take a look at this, there is no term with an x squared in it. All right, and the reason being is because if we put it in there, the reason it's gone is because anything times 0 is 0. So technically speaking, I keep calling it the lead coefficient. The coefficient of x squared, right, is actually going to be 0 in this case. So when you have a term that's missing, its coefficient is 0 because anything times 0 is 0, and so technically it's gone. So that's going to be important when we divide in section 4.8. It's kind of a missing, it's kind of a placeholder, if you would. So be careful with that. When you don't see a term, that means its coefficient is 0. And then number 4 has its own challenge because we notice, right, if we're going to find the coefficient of the x squared term, we notice that there's a term with x squared in it, and there's a term with x squared in it. So in order to find the coefficient of that, we're going to have to do the old idea of combining like terms. All right, and that actually, how about we revisit this in the next video? But in combining like terms, right, that's how I'm going to find this. So we're basically looking at, well, heck, let me finish it off. So we have -2/5 x squared and plus 1/2 x squared. So basically, the term we're looking at is the addition of those two fractions. Finding a common denominator, I believe it's 10, right? This would be -4/10, and this would be 5/10, giving us 1/10. So the coefficient then for the x squared term would be 1/10. All right, and so there we have it. And that kind of leads us into our next topic, where we're going to start simplifying polynomials and evaluating them. But hopefully this exercise, this video, got you used to the language, what it means, and how to do some of your homework problems. Alrighty, see you guys in the next video.